Alright, so I wanted to take a second, guys, to go through the practice problems from the PowerPoint, just so you could see those, or at least have solutions for them if you wanted to check them out. So I'm going to go through all of them. There's quite a few, or 5 or 6. So let's get started. So number 25 is a follow-up to the example question, and it says find the total force on Q3 if it is at the location x equals 0.25. Instead of 0.75. So, same setup as the example question. So we should have Q1 at the origin, and Q1 has a charge of negative 5.4 microcoulombs. Q3 is going to be a little bit closer this time. It's at 0.25. This is at x equals 0. This is Q3. Q3 has a charge of positive 1.6. And it's going to be at 0.25 this time. Oops, that should be a 2. And then we have Q2, which has a charge of negative 2.2 and is at 1 meter. So really the only difference here is the distances have changed, right? The distance here, instead of being 0.75, is going to be 0.25. And the distance here, instead of being 0.25, is going to be 0.75. All right, so let's set it up. First thing we want to do, right, is realize that there's two forces, right? They're both attractive. So we'll have, I'll draw a free body diagram so you guys can see what's going on, right? If this is Q3, right? That's embarrassing. Fixed it. This is Q3. We have a force this way. It's an electric force. And this, like, they call it in the problem 2-3, right? Because it's the force from charge Q, or from charge 2 on charge 3, or, right, do they call it 2-3 or 3-2? They call it 3-2. Sorry. 3-2. And then we have a force this way. That's from force 1, so this would be F3-1. So we have two forces, right? One's in the negative direction, one's in the positive direction from charge number 1 and from charge number 2. So first thing we have to do is find out what those forces are. So let's do the force from charge 1 first. K, absolute value. Now, just like in the practice problem or the example problem, this one's going to left, so it should be negative. So I'm going to throw a negative sign at the front. It's in the negative x direction. So negative K times Q1 times Q3 over R squared. We can plug in some numbers there. Negative 8.99 times 10 to the 9th times 5.4, right? Absolute value, we take the absolute value, so 5.4. And it's microcoulombs, so it's times 10 to the negative 6th times Q3, which is 1.6. Again, microcoulombs, so it's times 10 to the negative 6th divided by the distance, which has changed from 0.75 to 0.25, right? From 0 to 0.25 is 0.25. So we get 0.25 squared. All right, and now we're at the point where we're just doing some math on this, right? Depending on how you feel or what kind of calculator you have, right, you can plug all this into your calculator and be fine. If you don't have a scientific calculator, you could do it kind of the step-by-step way. I'll show you that way. So we multiply all the front numbers first. So the 8.99, the 5.4, and the 1.6. So 8.99 times 5.4 times 1.6 gives us negative 77.67. And then the tens, when we multiply numbers that all have the same base, right, 10, 10, and 10, we add the exponents. So 9 minus 6 minus 6, or 9 plus negative 6 plus negative 6 gives us negative 3. Divided by 0.25 squared gives us 0.0625. All right, and then we can divide those. So again, we could just divide the starting numbers. So negative 77.67 divided by 0.0625 will give us negative 1,242.8, we'll call it, times 10. There's nothing to do with the 10, right? Because there's no times 10 on the bottom. So it just stays as times 10 to the negative third. And then we could rewrite this because it's not necessarily in proper scientific notation, right? Proper scientific notation would have the decimal here. So we could change this to say, right, times 10 to the third means to set it up, we move the decimal place 3 places to the right. So to put it back, we can move the decimal place 3 places this way, 1, 2, 3. And we'll get the force is negative 1.24. And then we can cut off the rest because that doesn't really matter a whole lot now. So we get negative 1.24 newtons from force 1, or from charge 1. And then I'm gonna run out of space a little bit here, so I'll do it, try and squeeze it in at the bottom. All this work for one problem? Ridiculous. All right, so now we want to do the force from 2 on 3. Oh, I did it the wrong way again. 3, 2. From charge, on charge 3 from charge 2 equals, this one's going to be positive because it's to the right. So K Q2 Q3 over R squared. And we do the same thing. So 8.99 times 10 to the 9th times Q2, make it positive, 2.2. It's micro, so it's times 10 to the negative 6th. Q3, 1.6 times 10, again, micro to the negative 6th. Divided by distance from here to here, 0.75 squared. All right, I'm going to do this all really fast because I'm running out of space, so I'm going to do this in one step here. But 8.99 times 10 to the 9th times 2.2 times 10 to the negative 6th times 1.6 times 10 to the negative 6th divided by 0.75 squared. I got a force of 0.056 newtons. Which could be right, yeah. All right, let me just double check it, make sure I did everything right. 8.99 times 10 to the 9th, because that looks a little bit small. Not like drastically small, but just enough to make me check my math. Nope. All right, so there is our second force. So if we want to find the total force, right, and let's make it in a box right here, because again, I'm running out of space. We want to find the total force. Well, we have this to the left, this to the right. So the total force on 3 is going to be negative 1.24 plus 0.056. And we'll get negative 1.184 newtons. All right, so same kind of thing, right? We find the first force, find the second force, add them together, see what we get. All right, number 26. Given that Q equals positive 12 microcoulombs and D equals 16, so let me draw the picture first. So we have Q1, which is equal to positive Q. We have Q2, which is equal to negative 2.0 Q. And we have Q3, which is positive 3.0 Q. And Q, it tells us, is equal to positive 12 microcoulombs. And each of them is separated by a distance D. And D is equal to 16 centimeters. All right, so that's what we're working with. We want to find the total electrostatic force exerted on charge 1. So we want to find the force on Q1. All right, what's the force on Q1? All right, so we want to find the force on Q1, so I'm going to draw a little picture here. Let's talk about what forces are acting on Q1, just the direction first, so we know what we're doing. So if we talk about Q1 and Q2, right, negative, positive, there's going to be an attractive force that way, right? So we should get a force this way. That's going to be the force on charge 1 by charge 2. Here we have Q3, which is positive. Positive and positive, that's going to be repulsive. So we should get a force this way from charge 1 on because of charge 3. So F12, right, the force from Q2 is going to be to the right. F13, or the force from Q3, is going to be to the left. So that'll tell us what sign we should be using when we're doing these problems here. All right, so that gets me set up with kind of knowing which one's going to be positive, which one's going to be negative. Let's do the force from Q2 first. So F12 is going to equal K Q1 Q2 over r squared. It's positive, right? So we don't have to worry about putting a negative sign in front. So let's just go ahead and keep solving. We'll get 8.99 times 10 to the 9th times Q1. Now, it doesn't give us the actual number in the setup here. We have to figure it out. So Q1 is equal to positive Q, and Q is 12 microcoulombs. So this will be 12 times 10 to the negative 6th. Q2, it says is negative 2 negative 2 times Q. So that would be negative 24 microcoulombs. But we don't put in the negative sign because it's absolute value. So we'll get 24. Oh, I should write times 10 to the negative 6th, right? Not microcoulombs. We want the actual number in the problem here. Divided by D is 16 centimeters, which we don't want in centimeters, we want in meters, so 0.16 squared, right? We turn that into meters. Then we do our math. So depending on which way you want to do it, I'm going to do it the kind of long way if you don't have a nice calculator first. 8.99 times 12 times 24. Gives us 2,589.12. 9, 6, and 6, that'll give us times 10 to the negative 3rd, right? 9 plus negative 6 plus negative 6 gives us negative 3, divided by 0.16 squared gives us 0.0256. We can divide these two. So we take the 2,589.12 divided by 16 squared, which is the 0.0256, and we get a big number. $101,137.5 times 10 to the negative 3rd, right? And again, because this is such a big number on this side, right, it goes more than 3 places, we might as well just rewrite it so that it matches here, or so that we don't have to use this scientific notation. So we'll get F12 is equal to, move the decimal place 3 places, 1, 2, 3, 101.14, we'll round there, newtons. 101.14 newtons in the positive direction, 101.14. All right, so there is the force from Q2. Now let's do the force from Q3. So F13. This one's going to be negative because we decided it's going to be in the negative direction. So negative K, Q1, Q3 over R squared. Negative 8.99 times 10 to the 9th times Q1, which we already decided was 12, times 10 to the negative 6th. Q3 is 3 times Q, so 3 times 12 would give us 36 times 10 to the negative 6th, divided by, the distance here now is 2D, right? 1D and then 2D. D is 16 centimeters, so that's 32 centimeters, but we want it in meters, so 0.32 squared. All right. And then I'll do the math just on my calculator this time. Times 10 to the 9th times 12 times 10 to the negative 6th times 36 times 10 to the negative 6th will give us 3.88 on top divided by 0.32 squared, 0.1024, and we divide those two. Divided by our answer there will give us a force of, I forgot to add my negative sign, negative 37.9 newtons. So we get negative 37.9 newtons for our force there. So this one, right, 37.9, it's in the negative direction. So if we want to find the total, right, the force on charge 1 is going to be equal to 101.14 plus negative 37.9. 101.14 plus negative 37.9 is 63.24 newtons. There is the total force on our charge there. All right, there's 26. Man, 20 minutes to do 2 problems. Jesus. All right, 27. We have the same exact setup as the last problem, except we want to find the charge on Q2. So it's the exact same problem as 26, except we're finding the force on Q2 as opposed to finding the force on Q1. So Q is still 12 microcoulombs. D is still 16 centimeters. We still have Q1. I'm just going to write out what they're equal to this time instead of doing the positive Q1. So this one's going to be 12 microcoulombs. Q2 is going to be negative 24 microcoulombs. And Q3 is going to be positive 36 microcoulombs. All right, so there's those. D is still 16, right, centimeters, and that's the distance between them. This time we want to find the charge on Q2. So if we draw a little force diagram here of Q2, right, and what the charges are on it, well, positive and negative, so these ones should attract, so we'll get a force this way, right, that's F2, 3. The force on charge 2 by charge 3 is to the right. Positive and negative, we should get an attraction there. So we'll get an attractive force this way because of Q1. So F21 will be that way. And then we just have to solve, right? Just like we've been doing. So let's start with Q1. 21 equals K Q1 Q2 over R squared. This one's going to be negative, so I'll toss a negative sign out front. Negative 8.99 times 10 to the 9th times 12 times 10 to the negative 6th times 24. Again, absolute value, so it's always positive, times 10 to the negative 6th, divided by centimeters turned into meters, so 0.16 squared. We'll do this one the long way. 8.99 times 12. I don't know why I'm doing this math again because I could just look at the last problem, but whatever. Why am I doing math again? All right, so whatever. 2,589.12 times 10 to the negative 3rd, right? This one, if you're following along with me and if you're doing these problems at the same time, we just solved for in the last problem the force of Q2 on Q1. So if we're solving for Q1 on Q2 now, it's the exact same force. So we totally didn't even have to do all this math. We could have just said, we know that it's the same as from the last problem, but I already started. So divided by 0.0256. All right, and we get, excuse me, 101,137.5 times 10 to the negative third, and we can move that so that it becomes 101.38. Why did I change that to 3? Oh, I rounded right here. All right, so 101.14 newtons. 101.14 newtons. All right, so there is Q1. And again, if I've been paying attention, we don't even really have to do all that math because we know what it is already. F23 we have not done yet, but this one's going to be positive, so K is negative, negative, negative. Q2, Q3 over R squared. Keep going. 8.99 times 10 to the 9th times 24 times 10 to the negative 6th times 36 times 10 to the negative 6th divided by, this time, right, just D because we're talking about 2 and 3, so it's going to be 0.16 squared again. Let's do this, 8.99 times 10 to the 9th times 24 times 10 to the negative 6 times 36 times 10 to the negative 6th will give us 7.77 if we round, divided by 0.0256 divide by 0.0256, and we get a force of, am I still on? Yep. 303.41 newtons. All right, so there is 2, 3. We want to find the total. We add those two together. So force on charge 2 is going to be negative 101.14 plus positive 303.41. Negative 101.14 plus 303.41 gives us a total force of 202.27 newtons. All right, 202.27 newtons for the force on Q2. All right, I think we got a couple left here. Yeah, 3 left. All right, so 32. We have 3-point charges. Lie on the x-axis. Q1 is 9.9 at the origin, so let me make a little x-axis here. So our origin will be right here. This is Q1, which is 9.9 microcoulombs, positive. Q2 is at 12 centimeters. So here we have Q2. This is at x equals 0. Q2 is negative 5.1 microcoulombs. It is at what I saw, 12 centimeters? Yeah, 12 centimeters. And Q3 has a charge of 4.4 positive microcoulombs, and it is at 15 centimeters. And we want to find, what number is this? 32. This is number 32. We want to find the force on charge 3. So we want to focus on Q3 here. So let me draw a little picture so we know which way the forces are going, so I know whether to add them or subtract them. So Q3 is positive, so negative and positive would be attraction. So from Q2, right, so F on force 3, or R charge 3 because of charge 2 is going to be attractive. It goes to the left. Positive and positive, so we should get a repulsive force, which would go to the right. So Q1, force on particle 3 from charge 1 is going to be to the right? So Q1 positive, so it will repel the positive. Q2 negative, so it will attract the positive. So our force on 3 because of 2 will be negative. Our force on 3 because of 1 will be positive. So let's do charge 1 first. So we'll do force of 3 because of 1. That's going to be positive. So K, Q1, Q3 over R squared. 8.99 times 10 to the 9th times Q1 is 9.9 microcoulombs, so 9.9 times 10 to the negative 6th. Q3 is 4.4 microcoulombs, so 4.4 times 10 to the negative 6th. And the distance between them, this is at x equals 0, this is at x equals 15 centimeters, so the distance is 15 centimeters, which is 0.15 meters. So let's do some math. We'll do it the long way. 8.99 times 9.9 times 4.4. Gives me 391.6 times 10. 9 minus 6 is negative 3. 0.15 squared. 0.22? Nope. 0.0225. We divide the front numbers, so 391.6 divided by 0.0225 will give us 17,404.4 times 10 to the negative 3rd newtons, right? Negative 3 just dropped, times 10 to the negative 3 just drops down because there's nothing, no scientific notation on the bottom. We should fix this because it doesn't make sense to have a big number with a negative scientific notation. So F31 will be, move the decimal place 3 places, 17.4 newtons, right? 1, 2, 3. Yeah, 17.4 newtons. And that one is positive. All right, so there's the first one. Second one, we need F32. So the force on charge 3 because of charge 2. This one's going to be negative, we decided. So negative K, Q2, Q3 over R squared. Just to point out, right, and I don't know if I've mentioned this, where you put the Q1 and the Q2 and the Q3 doesn't matter, right? You can flip those. Because we're multiplying, it ends up canceling out and it doesn't matter. So if you're like confused, why is he putting Q2 there and not Q2 there? The answer is it doesn't matter. Equals negative 8.99 times 10 to the 9th times 5.1 times 10 to the negative 6th times 4.4 times 10 to the negative 6th, right? That's Q2, it's microcoulombs, divided by the distance here from 12 to 15 is 3 centimeters, so 0.03 squared. And let's do this math. I'm going to do this one fast. 8.99 times 10 to the 9th times 5.1 times 10 to the negative 6th times 4.4 times 10 to the negative 6th will give us 0.202 divided by 0.03 squared will give us 9 times 10 to the negative 4th. Then we divide those. 0.202 divided by second answer will give us 224.4 newtons. All right, so there's the force of 3. That one should be negative, right? Yeah, negative, negative. So when we want to find the total force, on particle 3, we'll take 17.4 plus negative 224.4, and that will give us 17.4 plus negative 202.4, 224.4. What am I doing? Negative 207. I definitely could have done that in my head. I don't know why I didn't. 207 newtons. Negative, right? Because the 3-2 force was bigger than the 3-1 force. So it'll end up being in the negative direction. So we get negative 207 point nothing newtons. All right, there is number 32. Um, 33 is the same problem again, just finding the force on Q2 as opposed to finding the force on Q3. So setup is the exact same as problem 32. We have Q1 at 9.9. We have Q2 at negative 5.1. And we have Q3 at 4.4, at 0, at 12, and at 15. All right, this time we're looking at the force on Q2 as opposed to the force on Q3. So let's check it out. Attractive force here from Q3, right? Pulling it to the right, opposites attract, so that's F23. Here we have another attractive force because of Q1, so that's F21. So again, going in opposite directions. This time, let's be a little bit smarter about this. We already solved for the force of particle 2 or charge 2 on charge 3. So the force from charge 3 to charge 2 has to be equal but opposite, right? If I show you here, right? F32 was to the left. F23 is going to be to the right. So these two forces are equal but in opposite directions. This is the force on 3 because of 2. This is the force on 2 because of 3. So they're equal and opposite. So I can actually just take my answer for 3, 2, which was negative 224.4, and make it positive. So F2, 3 is going to be positive 224.4 newtons. That way I don't have to go through and do that math again. All right. We don't have 1, 2, right? We did 1, 3, so we will still have to solve for this one. So F21 equals negative K Q1 Q2 over R squared. Negative 8.99 times 10 to the 9th times 9.9 times 10 to the negative 6th times 5.1 times 10 to the negative 6th divided by, this time it's 12 centimeters, so 0.12 squared. We just got to do that math there. So 8.99 times 9.9 times 5.1 will give us 453.9 times 10 to the negative 3rd. I'm smudging. 0.12 squared. I'm going to guess 0.0144. Nailed it. All right. We divide these front two, so 453.9 divided by 0.0144 will give us 31,520.8 times 10 to the negative 3rd. We should move the decimal place. 1, 2, 3 will give us, this one's supposed to be negative. I always drop off my negative sign. Negative 31.5 newtons. So there's our two forces. So the force on 2 will be 224.4 minus 31.5. So 224.4 minus 31.5 gives us a force of 192.9 newtons. There is the force on charge 2. Nice and easy that we already had that one to use. And last but not least, we have number 35, and there's a couple of questions in the practice parts that I gave you that are like this question, so this would be a good one to check out. In example 19.6, right, which was slide 4, the total force acting on charge Q3 is towards the right. To what value of X should Q3 be moved for the total force on it to be 0? So we want to go back to our practice problem, our example problem, where we had Q1, which was negative 5.4 microcoulombs at the origin, so at X equals 0. We had Q2 all the way out here, and that was, Q2 was negative 2.2 microcoulombs, and it was at 1 meter. And then we had Q3, and Q3 was in the middle. Right, we had two examples. One example where it was at 0.75, one example where it was at 0.25. It's 1.6 microcoulombs. This time, we don't know where it is. we want to figure out where it is so that we can find where the total force equals 0. So if we look at this, right, if we look at the forces acting on Q3, we have an attractive force because of Q2, right, so this is F3, 2. We have an attractive force because of Q1. This is F3, 1. If we want the total force to be 0 on on Q3, we need F3, 1 to equal F3, 2, right? If those two are equal, then it'll cancel out and it'll make this problem a lot easier for us. So I'm just going to jump into it, right, using this equation right here. So let's start with 3, 1. So K, Q1, Q3, voice crack, divided by, now what should we call this distance here, right? Because we're not really sure what the distance is. So I'm going to make the distance from here to here x, right? That's going to be x. And that'll be the distance that we're looking for. So this will be r squared. We'll have a value to put in for r there. This one will be k, q, 2, q3 over r squared. This will be a different r value, so we'll have to be careful about that. Before we jump all the way into it, we should realize a couple things, right? What's on both sides? Well, there's a k on both sides, so we can cross out k. And there's a q3 on both sides, so we can cross out q3. The r we can't cross out yet because the r's are going to be different. All right, so q1, actually, I could write the value of q1. I don't need to just write q1. So 5.4 times 10 to the negative 6th divided by x squared equals q2 is 2.2 times 10 to the negative 6th divided by, this one's a little bit tricky. So this one, I'm going to make the distance 1 minus x, right? Because this distance from here to here is the full distance, which is 1 meter, right? This full thing is 1 meter minus this part, so minus x. So the distance here is 1 minus x, whatever x is, squared. We do get another thing that helps us out a little bit. This and this will cancel. So we get 5.4 over x squared equals 2.2 over 1 minus x squared. We could cross multiply, right? That might make things a little bit easier so we don't have things in the denominator. So we'll have 5.4 times 1 minus x squared equals 2.2 x squared. So we should probably multiply out the x squared, or the 1 minus x squared. So we get 5.4 times, what do we get? 1.1, we should get 1 minus 2x plus x squared. Did I do that right? Now I'm going to have to double check. 1 minus x times 1 minus x. 1 minus x plus x squared. Yeah, I did it right. All right, cool. So we factor in the 5.4 here then. So we'll get 5.4 minus 10.8x plus 5.4x squared equals 2.2x squared. And it looks like we're gonna have to do a little quadratic formula here. So we subtracted 2.2, so we'll end up with 3.2 x squared, right? If we subtracted 2.2, that'll give us 3.2 x squared minus 10.8x plus 5.4 equals 0. All right, and then we have to solve that using the quadratic formula, which is opposite of b plus or minus the square root of b squared minus 4ac over 2a. Right, this is our a, this is our b, this is our c. I'm going to move over here just in case it takes me a couple lines. So opposite of b will be 10.8, right, because b was negative, so now it's positive 10.8, plus or minus the square root of 10.8 squared minus 4 times 3.2 times 5.4, and hopefully we get a positive there, divided by 2a is going to be 2 times 3.2. So let's do some stuff out here. We get 10.8 plus or minus square root of 10.8 squared is 116.64 minus 4 times 3.2 times 5.4 gives us 69.12 divided by 2 times 3.2 is going to be 6.4. Okay, so we can do the inside. 116.64 minus 69.12 gives us 47, so 10.8 plus or minus the square root of 47.52 divided by 6.4. We take the square root of that. We get I'm going to come up here. 10.8 plus or minus 6.9 divided by 6.4. So we'll actually get two answers here, right? Because both of these are going to be positive. We get two answers, one for the plus, one for the minus. But let's think about what our answer should be. So if we take 10.8 plus 6.9, that'll give us 17 something, right? And 17 divided by 6.4 will give us something that is bigger than 1, right? So can the charge be bigger than 1 if we want it to be between 0 and 1? Obviously not, right? It's not going to work. So what we need to do is do the subtraction. So the plus isn't going to work. We got to do the subtraction. So 10.8 minus 6.9 will give us 3.9 divided by 6.4 will give us 3.9 divided by 6.4, 0.61 meters. So if we want the forces to balance out, we have to put Q3 at 0.61 meters. And just to check if that makes sense, right? If we want the forces to balance out, because this charge is bigger and this charge is smaller, the charge will have to be closer to the smaller one than to the bigger one if we want the forces to match out. So at 0.61, it is closer to Q2 than it is to Q1, which makes sense. It's not bigger than 1, which makes sense. So that kind of checks out there. So that is number 35. All right, that is it. A whole hour, Jesus Christ.